So I'm doing 11-8 and so the for part A, one it asks which end of the tether is negative. So based on the right hand rule, where you use your right hand like this hand, you rotate your palm and your thumb to do stuff, and it turns out that the shuttle end is negative. Yay! For part two, alright, this is where it gets tricky. It's asking you to calculate the magnitude of the EMF generated. So, use this equation. QE equals QVB. And you should know what these symbols are, because you're in physics. Alright, so the Q's cancel out, so it's just E equals VB. And if we use V for EMF, then the EMF is just the electric field, which is E, multiplied by the length, which is L. So V equals E times L. So V equals VBL. And we already have all those in the givens. So it's basically 7,600 meters per second times 3.3 times 10 to the negative fifth Teslas, which is the B, times 20 times 10 to the third meters, because it's 20 kilometers, so you have to remember that it's 20 times 10 to the third, and that gives you 5,016 V. I don't know what V stands for. Anyways, for B, use Ohm's law, because it asks you to calculate the current, and it's giving you the resistance. So I equals V over R. And you're already given V, which is 5,016. And then you just divide that by 10,000, which is what you're given in the problem, and you get 0.5016 amperes. Yeah, that's not so bad. Part C. So part C asks for the magnitude of the force in part 1. And so the magnitude of the force is represented by this equation, which is current times derivative of length cross B. And since the current is perpendicular to the field, which we figured out in another part of the problem, I think, the actual equation is this: F equals I L B. And then you just plug in all your little numbers. We calculated 0.5016 amperes of the current. Length we know as 20 times 10 to the third meters. And then we multiply it by B, the Teslas. I don't know.
Move your book.
And you get 0.331 newtons. Wait, is it newtons? Yes, newtons. Anyways, that's A, B, and C. Now I have to... Actually, that's only part 1 of C. 1 second.
This is only the first page. I need the second page.
Stop! I'm recording right now. You can't do this. Okay, for part 2. Right here, it's asking you for the direction of the force. And you just use your right hand, and this is my right hand again. This is my thumb, and this is my palm. So, based on that, the magnetic force is opposite to the shell's velocity. Alright, we're done. Alright, no, this is part D. Hey, 1 second. Alright, for part D, it asks you for the orbital energy change. So, the equation for energy. The equation for energy is change in potential equals P times T. So remember this other equation that's on your equation sheet too? It's P equals I squared R. It's just on your equation sheet. I don't know what it's called. So you basically combine the two equations and you get this equation, I squared R times T. And then you just substitute everything, which, crap. So we already have I, which is 0.5016 amperes. So you do that squared, and then you multiply. You multiply by the resistance. Is it? Yeah. And then you multiply it by the time, which is well, we want it in seconds, but they give us 7 days, right? So you multiply by 7 for the days, and you multiply by 24 for the hours, and then you multiply it by 60 for the minutes, and then you multiply by 60 for the seconds. This is basically stoichiometry, which you should have done with Mr. Allender, who's a cool teacher. Anyways, can you not? What are you doing? Well, anyways, that gives you 1.52 times 10 to the 9 joules. Joules, yeah. Joules. Alright, part E. Why do you keep touching me? I can't see it. Part E. Alright, part E asks you to imagine, to use your imagination, to imagine that the astronauts are forced a current to flow the other way. What effect would that have, if any, on the orbit of the shuttle? Explain briefly. So, if the current was forced to flow the other way, the direction of the magnetic force on the current would be reversed. This force would do work on the shuttle, and the resulting gain of energy would cause an increase in the radius of the orbit. It would boost the orbit. And that is 11-8, explained by Gabriel Wei. Thank you very much.